Hello and welcome to an ANSYS Workbench tutorial on beams with non-symmetric cross-sections. In this tutorial we're going to look at an angle beam, an L beam, that is cantilevered with an end load. This beam that we're going to use as a standard beam is defined by the American Institute of Steel Construction, or the AISC. So we will download the cross-section from the internet, and then we will develop our cantilever beam model. Then we'll validate the stresses, the neutral axis, and we'll look at the angle of twist due to the loading. The other thing that we're going to do is we're going to scale the entire beam, or the entire cross-section in this case, because the units as they are brought in from a DWG file always come in as metric units, and the American Institute of Steel Construction is based on English units. So to begin with, we will go to our lab handout where we can click and copy the website where we'll download the DWG files. Control C, then I can bring up a web page, paste that website, and it takes me to this CAD Steel North America website. I'll come over to menu and I'll click on steel sections, and this lists all the steel sections that are defined as standard sections by the AISC. Since we're going to do an L shape, I'll come here and click on L shapes, and as I scroll down, this brings up all the possible L shapes that I can get. So in this case, the first number represents one side of the L, the second number represents the other side of the L, and the third number here represents the thickness of the L. So in this case I'm going to do a 5 by 5 by 0.75, so I'll hunt and find that in the menu. Here's my 5575. I can click on that, bring me to a download page where I can click on download DWG file. It's downloaded, and now I need to take and bring this file into my working directory, and I'm going to assume that you can do that. So I'll minimize my website or my internet window. I'll come over to my ANSYS Workbench project menu, and I'll import. The file that I'm going to import is that geometry, the DWG file. It shows up in my directory as a PDF file, but it's not really a PDF file, it's a DWG. So I'll click on open. You can see that it brings in my geometry, and I have a green check, so I'm going to go look at my geometry. And while space claim is coming up, I'll go ahead and pause the video. When space claim comes up, it gives you your pop-up window. You can close that, and then you can see that it's brought in the cross-section is lines and arcs. So what we need to do is take these lines and arcs and actually create a surface that we can then pull to give us our cantilever beam. So to do that, I'm going to come and left click on the top line, shift left click on the bottom, and then come over to my fill edit tool and click on fill, and you can see now that it has now filled that enclosure and turned it into a surface. So I have this surface here now, and I can go ahead and delete these other lines. So I will click on it, then right click and click delete, and now I have my cross section. Now this was supposed to be a cross section with 5 inches by 5 inches, and if we come up here to measure, click on my caliper and then come down and click this line, you can see that it's actually 5 millimeters. So we need to come and scale this entire cross section such that this is 5 inches by 5 inches, and then the 0.75. So to do that, we'll come back to design, and we'll go to our sketch tools, and this right here is the scale command. So I'll go ahead and click on scale. I'll come over here and click my surface, and then when I come over and click on my surface, I have my whole body, and I can enter values in here. I want to actually enter these in terms of English units, so I'm going to come back to File, Space Claim Options, come to Units, change to Imperial Inches, and scroll down and make sure my minor grid spacing is 0.1 inch, and I have 10 grid lines per major. So I'll click OK, and now you can see that my dimensions are shown in inches. And so what I want to do here is click on that dimension and type in a 5, enter. Click on this dimension, enter 5, and now I need to scroll out so that I can see my cross section, and this dimension should be scaled appropriately based on the dimensions that I've already scaled. So now I can move this to the center, and I can go ahead and come back to my design and pull this into my cantilever beam. So I'll go ahead and click on surface. I'm on my pool, and I'll grab this surface and click the surface, pool. What I actually need to do is go to 3D mode and then select the surface, and now I can pull it. So as I pull this out, I'm going to go ahead and enter the length of the beam, which is 36 inches. So just simply enter 36 as the dimension. And there's my cantilever beam. You can see that I have one solid over here. I could make that a parameter, but I'm going to go ahead and just leave that length. I can come here and rotate my beam all around. It looks like what I want, what I expect. So I'm going to go ahead and save this. If you don't save your file right now before you go in to open it in Mechanical, you will not be able to do it. It'll give you some errors. So I'm going to go ahead and click File, Save As, and I'm going to save this to my working directory that I've been working in, and I'm going to save it as L beam scaled 2. So I've saved that now. Now I can come over and grab a static structural, drag it and drop it on top of my geometry, and you can see that it ties the geometry to my static structural, and I'm ready to go ahead and click on Model. I'll double click on Model, so I'm starting Mechanical, and while that's coming up, I'll go ahead and pause the video. So Mechanical is opened. You can see that it is showing its dimensions in terms of millimeters. So I want to come up here and click on my units and pick US customary, and now things are being shown in terms of inches. My geometry is brought in. I got a green check. My coordinate systems are okay. I can click on mesh. I'm going to go down and change the sizing to at least a medium on the size. So on the relevant center, I'll click medium, and now go ahead and click update the mesh. Should mesh relatively quickly as it's a simple geometry. I get a really nice clean mesh. I'm going to go ahead and increase this and actually reduce the size of the elements and click Fine, and then click Update. If this gives me too many, I could just refine the mesh at one end, but for this simple geometry I certainly can handle that many elements. So now I come to static structural. I click on my loads. I'm going to enter a force, and I'm going to pick this end face, click apply. I'm going to change the vector to components. I'll give it a minus 5,000 pound load. Then I'll come up to supports, and I'll enter a fixed support. I'll choose the other end, click that surface, click apply. So So now I have my loads and my boundary conditions applied. In terms of my output, I want to look at the total deformation. In terms of stress, I'll look at the von Mises stress. I'll also look at the normal stress. Now I can go ahead and right click on solution and click solve. While this is solving, I'll pause the video. So my model is now solved. I can go ahead and look at the various quantities. There's my total deformation, my equivalent stress, and my normal stress. And what I want to look at here is to make sure that the results look as I expected. So I'll go ahead and rotate this to look at the stresses. That's my free end, so I want to look at the end where my stresses are. So I'll look at this negative Z direction, and as I look at this cross section, I can see the blue here, which is a very low stress, kind of propagates through my member like that. I can see that my highest stresses are in these corners, and so I can go in now and hand calculate my angle to my neutral axis and verify that it's in this direction and that my largest stresses should be at these corners. I can also look at the normal stress, and here on the normal stress it won't all be positive, but I'll have tension and compression. You can see that my zero kind of crosses through this lighter green, so again I've kind of got my neutral axis angle coming through here, and my maximum stresses occur down here in this corner and up here. Now if I want to look at the total deformation, I don't want to look at the fixed end, so I'll swing this around and look at the other Z dimension, which would be the negative Z, and I'll just rotate it around and get that. And here are my deflections. Let's move this up so that we can see it a little bit better. You can see that my total deformation down here is red, and then up here I also have a deformation. What this can tell you right here is that you're getting an opening of this beam, because you get more deflection down in this region here where I'm red as compared to this orange section up here. And so although it's a little bit hard to see, my angle has opened as expected due to the end load and the non-symmetric cross section. I hope you've enjoyed this video, and if you have any questions, please feel free to ask them in class. Thanks.